Okay, this is term 2 week 9 maths A. I'm gonna fly through this because, well, it's very easy, okay? And you guys did the periodic. The diagram shows the results on a coding test for two groups of students labeled class M and class N. The mean score for class M is 59.5 and the mean score for N is 62. Students pass this test when they score 50 or above. This is the passing 50 or above. Okay. So as you can see, data here, whatever. Yep. Looking at the mean scores, the students from class N claim they did better than class M at that test. Okay, for class N, did better than class M. That's what they're claiming. Okay, for the yellow ones, they're saying they did better than the gray ones. Give one mathematical argument using the graph that the students in M can use to show that class N may not have done better. Okay, so we're going to go through them one by one. If you ignore the weakest two scores in class M, the students in class M did better than N. So let's see, the weakest two in M are this one and this one. If you ignore these, overall, M did better than N. Let's take a look. Sorry. When we say ignore the weakest two scores, it means this one only. Why? Because it's two students. For these two scores, ignore them. Then M did better than N. Let's take a look. Yes, because if you ignore these, then the rest of M are all passes. But as you can see, N here has a fail. Okay, which that's correct. More students in class M scored 80 or above. Let's take a look. More students in class M scored 80. As you can see, yes. In N, only 1. But in M, it's 2. So that's correct as well. More students in M than N passed the test. Let's take a look. How many people passed? Passes is above 50, okay? 50 or above. So you have 4 here, so that's 8. Plus 2 here, that's 10. Let's take a look at N. You have 2, 3, so that's 5. Plus here, 3, 8. Plus 1, 9. Okay, so if you compare the two, M has higher. So since we have all 3 correct, we choose all of the above. Question, this might have been this might be the hardest question in the whole quiz, huh? A cyclist rode 3 consecutive laps around a flat 10-kilometer track. This shows how the speed of the cyclist varies on his second lap around the track. The origin of the graph refers to the starting point. Okay. What is the approximate distance from the starting line to the beginning of the longest straight section of the track? Okay, these questions are kind of weird, Saraha. But let's take a look here. You have the speed and you have the distance. They're saying from the starting line, from here to the beginning of the longest straight section. If you look at the straight sections, this one here is about 1 kilometer. Each square represents half, huh? And this one here is about, I don't know, about 1 and 1.6 kilometers. And this one here is 1 kilometer. Okay, so which one's the longest straight section? It's this one. So this is what you have to identify. You have to identify which is the longest straight one. Okay, and then find the distance from the start line to there. We're going to go like this. Okay, how far is it? 5 kilometers. Okay, very easy. Part B, they say, where was the lowest speed during the second lap? So where was the lowest speed? The lowest speed was over here, as you can see, just 8. I think that's very, very easy. Let's take a look. Part 3, what can you say about the speed of the cyclist between the 4 kilometer and 5 kilometer mark? Between 4 and 5, as you can see, it's increasing. I think really if you're in 11S and you find this hard, here are the pictures of 5 tracks. In each track, S marks the starting point. Along which one of these tracks was the cyclist riding to produce the speed graph shown earlier? So I think it's pretty obvious. Let's take a look. So this one's kind of tricky. Please don't think this is a hill. Oh, this is not a hill. It's not a mountain he goes down and up, like, no. That's not what it means. Well, it actually, wait, it might be. Hold up. I think I think it actually is a hill. Let's solve it as if it's a hill. If this is S, let's start with A. We do by elimination, okay? Why isn't it A? It's not A because here it starts and it falls, so it should be gaining speed. However, initially, we're losing speed, right? So that means you're going up. So we're going to take a look at which ones go up. And this one's the only one that doesn't. Now we're going to look at B, C, D, and E. We kind of finished that starting point. We reached here now, right? We lost velocity. This one is wrong because it's supposed to, here it's saying it stays constant. Okay, although it does stay constant, stays constant for a pretty short time, and then goes back down again. Okay, so it goes back down again, then goes back up. So what does that mean? We're gonna go back down again. We stay constant, عادي, and then it goes back down again. Wait, بس I'm lucky lost ولا. I'm gonna ask AI. Hold up. Yeah, guys, I'm so cooked. AI is giving me a wrong answer. I don't know. I still don't know why it's B. It doesn't look like it's صراحة. Oh, wait. I get it. I think I get it. Wait. Wallah, I think I get it. Look. Like I said at the start, it's not a hill. Okay. Here, since you're turning, he has to slow down. Okay, so he slows. Okay, then he continues straight over here. Right? Straight. Okay. Then he has to slow down again and turn because it's a curve. You guys know on curves you have to slow down. Okay. Then it's a long straight. Okay. Then he slows down again to turn, and then it's long straight again. Okay, let's see. Slows down, then reaches a straight, then has to slow down to curve, and then reaches a long straight path, and slows down a lot until he reaches a straight path again. You see? I think that's why it's B. Okay, over here, I think it's because he slows down, but he doesn't really stay straight for a while. Okay, and then slows down again, so that don't work. Here, slows down, stay straight, slows down, stay straight, slows down, stay straight. Okay, but they're all like the same length, as you can see here. This one's obviously wrong. This one he slows down, stays straight, then slows down, and then I don't know what he does here. So this is wrong. I don't really get what's happening here. But I think it's related to the second straight path being the longest. Here the second straight path is short, if that's wrong. Here the second straight path is the longest. Here it's not as short, it's over here, you see. Okay, I think it's related to that one. Question 3. A research team is building wind power stations. The stations use the power of wind to create energy. The research team measures electrical energy in kilowatt hour. The team builds the model with the following specifications. The height 180 meters, blades 3, one blades 25 meters, maximum speed 20 rotations, price for construction 2,400,000 Zs, turnover 0.10 Zs per kilowatt hour generated, maintenance cost 0.01 Zs per kilowatt hour generated, efficiency operation 97% of the year. Which of the following statements can be deduced from the specifications of the model? Let's see. The maintenance cost of the power station corresponds to approximately 10% of its turnover. Let's see. What is the turnover? Turnover is 0.10. What is 10% of 0.10? You guys know to find 10%, you write 0.1. Or some people write 10 over 100. That's completely fine. Okay, 10% of the turnover, which is 0.1. Look at what you know. Its maintenance cost is 0.01. And as you can see, we got 0.01. Correct. The maintenance cost of the power station depends on the speed of the wind. Does it say anything here? No, they said per kilowatt hour generated. Okay. Kilowatt hour. But this can. Okay, they didn't say anything about speed of the wind. But this is a question mark because I feel like the speed of the wind would get more kilowatt hours generated. So it technically does make sense. I'm not convinced with it, but خلاص, put it, I guess. The power station is not operated on exactly 3 days a year. They didn't say this anywhere. The construction of 3 such power stations would cost more than 7 million in total. Let's see, of 3, so 2.4 times 3. You can do 2,400,000 times 3. It's easier. 7.2 million. It will be more than 7 million, yes. The research team proposed the following equation to estimate the financial gain GZs over a number of years if they build the model described above. So the gain G is equal to 600,000 Y, being the profit from yearly production of electricity, minus 2,400,000 being the cost of building the power station. So Y obviously represents the years, because 600,000 times the number of years. He said profit from yearly production of electricity. And then 2,400,000 is the cost. Based on this formula, what is the minimum number of years to recover the cost of construction of the power station? So think about it like this. Every year they're making 600,000. Okay, so 600,000 every year. But don't forget they spent 2,400,000 on actually constructing it. Okay, so how many years do we need to kind of make back our money to break even, as they see in business terms? Just check each year if you want. Or it's kind of obvious it's 4. Okay, 600,000. Let's try times 2. you're gonna get 1,200,000, which is less than that. So you're still gonna be in debt. How about 4 years? If you do 600,000 times 4, you get 2,400,000. So now you will break even. What is the maximum speed that the end of the rotor blades move? Let's take a look. It's 20 rotations per minute. Okay, for this question actually needs a bit of thinking. I'm gonna draw it for you so you can kind of get what's happening. So you have, this is your wind blades. Okay, so it's a big circle, not really a circle. Okay, I'll draw it better. Hey, can you have this circle over here? And then you have 1, 2, 3. Type, how much is the length of this? 25 meters, right? It's given here. Okay, and they're saying that its maximum speed is 20 rotations per minute. Type, is rotations 20 rotations per minute. Is rotations at a distance, is it a length? طب what do I know? How much is rotation? أصلا do I know how much one rotation is? No, I don't. طب okay guys, what is this? What shape is this? It's a circle. So to find the length of the rotation, can't I just find the circumference of that circle? Yes, circumference is 2 pi r, right? طيب المشكلة, someone's gonna come tell me, طب what's the radius? Man, they gave it to you 25. It's gonna be 2 pi times 25, which is 50. So it's 20 rotations per minute, so 20 times 50 meters per minute. يعني per minute 100 meters, ولا 1000, 20 times 50, 1000. 1000 meters per minute. طيب, let's see. That's not one of the options. We have in meters per second and kilometers per hour. Let's convert this to kilometers per hour. 1000 meters in 1 minute, right? I think all of you know how to convert to kilometers per hour. طيب, let's first convert to meters. How do you convert to meters? You divide by... sorry, let's first convert to kilometers. My bad. And before this is 2 times 25, 50 pi, huh? I forgot to put the pi. Okay, so 1000 pi over here. So 1000 pi meters per minute. Okay, you want to convert to kilometers, you divide by 1000, right? And then to convert from minutes to hours, what do you do? How many minutes do you have in 1 hour? You have 60 minutes. Someone might ask, why are you multiplying by 60? And I don't want to show you, I'll just show you the wrong way. We have 1000 pi meters per minute. Okay, you first start by cancelling the minutes. You want to go from kilometers to minutes, right? We know that 1 kilometer is 1000 meters. We know 1 kilometer is 1000 meters. So you need to cancel the meters. This is grade 5 stuff, grade 6 stuff. You need to cancel the meters. Okay, so do you put the meters up or down? Obviously down. So 1000 meters, we're going to put it down. 1 kilometer up. This way you can cancel M with M. Okay, and now you want to cancel minutes. We know that 1 hour is 60 minutes. Right? Type, do I put the minutes up or down to cancel it? I need to put it up. So 60 minutes over 1 hour. So you can cancel now minutes with minutes. So you're going to get 1000 cancels with 1000. You're going to be left with pi times 60. 60 pi kilometers per hour. Okay, and 60 times pi is just 188. Okay, so this is correct. If you want to convert to meters per second, you just divide by 3.6, huh? But this isn't any of the options, so meters per second, there's no option for it. So 188 is our kilometers per hour. Question 4. Select the figure above that fits the below description. In triangle KLM, it's a right one with the right angle at K. So immediately this is wrong because K here isn't right. And immediately this is wrong because K isn't right. And immediately this is wrong. And okay, so you're left with B, E, F. We know that the line KM is less than KL. Let's take a look. KM is less than KL. So obviously here it's less, so this one might be correct. It's correct. This one KM less than KL, is it? KM is less than KL here? No, look how long KM is, look how KL is. Wrong. KM here is less than KL. So we're left to 2 options, B and F. N is the midpoint of the line KM. N is the midpoint of the line KM. It's the midpoint, both of them. And P is the midpoint of KL. P is the midpoint of KL for both of these. So still, we're not sure for sure. Q is a point inside the triangle KLM. Let's see, Q, where's Q? Q is part of KLM. Let's draw KLM. KLM, it's our triangle, right? Here, is Q inside of it? Is it inside of the triangle? Yes. How about here? Q, is it inside the triangle? No, it's on the triangle. There's a difference between on and in. Okay, here it's inside, so we're gonna take now what? B. This is wrong, because it's on the triangle, not inside of it. Okay, and then they said line PN is greater than line PQ. PN and PQ, here they're the same. As you can see, PN and PQ, they're the same, it's not greater. But here PN is greater than PQ. So that's another observation that you may deduce. Okay, the function f is defined by f of x is equal to 4 minus 5 sine x between minus pi over 2 and pi. The function g is defined by g of x is 4 minus 5 sine x minus pi over 2 and a p, where p is a constant. This came in your periodic. I sent it as a message in the grade 11 group chat. I sent, guys, please solve top question 35. It's going to come in your periodic in the computer. Okay? But, well, nobody solved it. Yeah, I don't know why. Type, the range of f. 4 minus 5 sine x. What's usually the minimum and maximum value? The minimum and the max. The minimum is usually -5 and the max is what? 5. But we're adding 4. So what do you do? 9 and -1. Okay, so from -1 till 9. So we always go from smallest to biggest. Huh? The graph of f passes through 0, pi over 2, and pi something. How do we do this? Open your nice calculator, change it to radians. 4 minus 5 sine 0, you get 4. 4 minus 5 sine pi over 2, you get -1. 4 minus 5 sine what did he say? Pi. You also get 4. So if you want to graph this, this looks like this: 0, 4, so over here, pi over 2, -1, okay, and then pi 4. So it goes like this, right? Type, they're gonna say now, which of the following is the largest value for p, which g has an inverse? Remember, which g has an inverse. How do you do this when you want to find the inverse? You see the longest, the furthest point as to which it doesn't change, increasing or decreasing. So we're starting g, we're starting at minus pi over 2. Okay, we're starting at minus pi over 2, which is, if you don't believe me, minus pi over 2 should be over here at -4. You can do it in the calculator if you want. Okay, or no, wait. No, minus pi over 2 is not here. Minus pi over 2 will be higher. Minus pi over 2 will be 9. Minus pi over 2 will be here. Heck. Anyways, minus pi over 2 will be here. So we're starting at minus pi over 2. We want to see this value p. What's the greatest value of p for which sine has an inverse here? Okay, remember, for which sine has an inverse, if you want my advice, just looking here, it's usually the middle one. Usually. Okay, but I'm not going to tell you this because I think in the exam it wasn't the middle one. Okay, take a look here. Here, from 4 to -1, what did you do? You decreased. Then from -1 to 4, you increased. Usually, the turning point, that's when, that's the largest value for the inverse. Okay, and what is it? Pi over 2. If you don't want to graph, just do this, okay? Because it works in the exam. Just look at the turning point. See, here it was decreasing, then here it was increasing, and here's the turning point. So take that as the inverse. If you want from the graph, as you can see here, it's decreasing until it hits here. Remember, if you continue to anything above pi over 2, then there will be no more inverse. You can't. It's either all decreasing or either all increasing. You can't. Okay, you're going to take the decreasing part since they started at minus pi over 2. Okay, and you're going to go over here. It keeps decreasing until pi over 2, until where it starts increasing afterwards. So that's why pi over 2 here is correct. From the value of p from part C, which of the following gives an expression for g inverse of x? G inverse of x. نحن اتفقنا هيدي 4 minus y is equal to, or f of x is equal to 4 minus 5 sine x. How do we find the inverse? You interchange y and x. So 4 minus 5 sine y is equal to x. For there, you're going to get minus 5 sine y is equal to x minus 4. Divide now by minus 5, divide by minus 5. This cancels. You're going to get this, right? So I always tell you, when you get an expression where the negative is in the denominator and you have like a binomial something minus something, okay, you just, to get the negative out, you can take the negative out by switching these two, okay? The actual proof of this, by the way, is just multiplying by -1 up and down, okay? Because when you multiply by -1 here, it cancels the negative. When you multiply by -1 here, it becomes 4 minus x, okay? This is just a simplification thing you need to learn. You need to be quick with it. Okay, whenever you have a negative in the denominator, just take that negative out by switching these two together. Okay, and you're going to get sine y is equal to this. Now, what do you do? It's sine inverse 4 minus x over 5. Okay, question 6. If cosine x is minus 12 over 13, then 26 sine x is what? Okay, it's quadrant 3, huh? 180 and 270. So from here to here. So we're working here in quadrant 3. Okay? Type quadrant 3, sine is what? Sine is negative. So when you take the root, you have to take the negative root. Okay, remember, when you relate sine x to cosine x, sine x is equal to square root 1 minus cosine squared x. Okay, I'm not taking my time anymore because خلاص, I'm going fast. We're going to take the negative root. Why negative? Because اتفقنا no, we're in quadrant 3, so sine is negative. Okay, so negative root 1 minus cosine squared x. So 1 minus minus 12 over 13 kilo squared. And then multiply by 26, you get -10. Question 7. If cosine x is minus root 3 sine x, then what is it? 150. Okay, so we did this a million times. Divide by cosine x on both sides. Okay, cancel. You're going to get tan x times negative root 3 is equal to 1. Divide by negative root 3, you're going to get tan x is equal to 1 over negative 1 over root 3. If you want to just do this in your calculator, okay, ignore the table if you want. You're going to get 1 over negative root 3. You're going to get negative 30. But for tan, what do we do? Does it fit in the domain? No. So what do? We do plus 180 for tan, right? So it takes to 150. Question 8. What is the value of r here? How do you find r? It's just the magnitude. So square root 4 square plus, in brackets, 2 root 21 square. You get 10. Question 9. W of x is this. We want to find the integral of 100 cosine 4x. Always, the constant, you take it to the side. Cosine 4x, what's the rule for it? It's 1 over a. So 1 over 4 times cosine gets you sine. Integral cosine is sine 4x. Okay. Then 100 divided by 4 is 25. It becomes 25 sine 4x. And aquí you have plus c. Huh? Question 10. Given f of x is 2x minus 3 and g of x is x squared minus 1, find f of g of minus 2. This is a very nice, cute, petite question. We love to see these. In the exam, I think it was 12. I'm not sure. Anyways, f of g of minus 2. First, you want to find g of minus 2. What's g of minus 2? It's minus 2 squared minus 1. Okay, you're going to get 3. Then substitute 3. 2 times 3 minus 3. 3. I'm not going to waste time on this question. Okay, find the value of x. Here, in the exam, the answer was 3. Huh? If it might come the same, I'm not sure. Okay, but I remember it was 3. Type. What do? I always call it A, B, C. Okay, and then D, E. Okay, and then how do I always relate triangle ABC to ADE somehow. Type. A is obviously congruent to itself, so it's equal to A. B is congruent, it's this angle here. In this triangle here, which one is it? Let me draw the triangle right over here. Obviously, it's not D, and it's not A because A, we already said it's congruent to A. It's not D because this is a right angle, yani. Okay, so what's left? C. E. Okay, and the last one left is just D. Obviously, C is congruent. The right angle is congruent to the right angle D. Okay, this is how I do it. That means AB over AC is equal to AE over AD. Right? What's AB? AB is 8 على AC which is 4 plus x is equal to AE over AD. AE, where is AE? AE is over here, 4. AD is what? 3. Okay, yeah, so how do you solve this? Cross multiplication. Why do I feel like I'm doing something wrong? You're gonna get 24 is equal to 16 plus 4x. You're gonna get 4x is equal to 8, but I'm correct. X is equal to 2. Question 12. Consider the equation 5 cosine theta plus 10 sine theta is equal to 7. Empty 0 pi. You can rewrite it, obviously, guys. Cosine theta plus sine theta, you can rewrite it as r cosine theta minus alpha. Remember? What's r? It's the magnitude of it. So square root of 5 squared plus 10 squared, right? So root 5 squared plus 10 squared. So which is, they just want the value of a, they don't want the actual radical. So we're going to do it 125. What's the value of tan b? Remember, the rule is tan alpha is equal to b over a, b being the coefficient of sine and a being the coefficient of cosine. So 10 over 5 is equal to 2. Okay, you don't need a calculator for that. Okay. Question 13, y is equal to 10 sine 6x. What is the derivative? Okay, remember, constant, always take it to the side. Derivative of sine, cosine. Okay, sine 6x becomes cosine 6x. But remember, when working with trig, sine ax, okay, or any sine u, actually, sine u, it's equal to cosine u times u prime, right? You can't forget this u here. Okay, so what's the derivative of 6x? What's u prime in this case? 6. 10 times 6, 60, cosine 6x. Please don't neglect these. The derivatives of trigonometric functions are very, very, very important moving into grade 12. Okay, you need to know them. Y is minus 12 cosine 4x. What's y prime? Again, constants, always take it to the side. Derivative of cosine is negative sine 4x. And remember, you always can't forget that u, so times u prime, so times derivative of 4x is just 4. 4 times minus 12 times minus becomes positive, right? So it becomes 48 sine 4x. Question 15, and I'm flying through these because really we had periodic on them, huh? 8 cosine 9x becomes what? Always constant to the side. Derivative of cosine, negative sine. And you can't forget the 9x, right? Times, always, u prime. What's the derivative of 9x? 9. 9 times 8. Can't forget the negative. Negative 72 sine 9x. Okay? Very nice, very calm, very easy. Question 16. If it wants to load. No STP freeze. Okay, integral 60 sine 6x, always coefficient, take it to the side. Integral of sine, always when working with integral, you do times 1 over a, right? So 1 over 6 times integral of sine is what? Negative cosine. Obviously 6x and then plus c. This gets you 10, but you have the negative, so negative 10 cosine 6x plus c. Question 17. Integral 24 cosine 8x. Again, constant, you take it outside. 1 over a, so times 1 over 8. Times integral of cosine is sine 8x plus c. Cancel, you get 3 sine 8x plus c. Question 18. Tan x is equal to 7 over 5. What is secant squared? Secant squared is equal to 1 plus tan squared, right? So 1 plus 7 over 5 squared. Let's do it. 1 plus 7 over 5 over here outside squared. You get 74 over 25, so k is 74. Question 19. Given cotan x is 5 over 4, what is cosecant squared? 1 plus cotan squared is equal to cosecant squared. يا صرنا حافظين الفورمولاز نحن. Okay, 1 plus cotan squared, so 1 plus 5 over 4 square. 41 over 16, so k is 41. Easy. Given sine a, cosine a, sine b, cosine b, what is cosine a plus b? Cosine a plus b is cosine a, cosine b, minus sine a, sine b. Cosine a is 20 over 29. Cosine b is 4 over 5, minus sine a, 21 over 29, times sine b, which is 3 over 5. 17 over 145. So k is 17. I'm flying through them because like I told you, and I want to finish, and it's very easy. Cosine a minus b, same formula, but what do you do now? Plus, right? Plus, sorry, sine a sine b. Okay, يلا on the calculator. Cosine a cosine b, so 12 over 13. Cosine b is 4 over 5. Plus sine a, 5 over 13. Sine b, which is 3 over 5. 63 over 65. So k is 63. Question 22. What is tan a minus b? Remember, tan a minus b is tan a minus tan b over 1 plus tan a tan b. Okay? So let's do it. Tan a minus tan b, so 4 over 3 minus tan b, 5 over 12 على tan 1 plus tan a tan b, so 1 plus tan a tan b, so in brackets tan a 4 over 3 times tan b 5 over 12, 33 over 56. Okay, is 33. Question 23. What is cosine a plus b? Obviously here it's in first quadrant, for both cosine sine they're positive. You don't need to take the negative root, but we need to know cosine a plus b. We know it's cosine a cosine b minus sine a sine b. So what are we missing? We need to find cosine a, we need to find sine b. How do we find cosine b? Cosine a. Given sine a, cosine a is cosine 1 is root 1 minus sine squared a. Right, so let's do it fast on our calculator. Root 1 minus sine squared a, so 21 over 29 squared. So 20 over 29. Remember, we're taking the positive root because they said first quadrant. Okay, then sine b, I won't write it. So using the same root, sine b will just be root 1 minus cosine b squared, right? So for sine b, yeah, I'll write it actually. Sine b is square root 1 minus cosine squared a. Right, so 1 minus cosine squared a, so 1 minus 4 over 5 squared, so 3 over 5. طيب, let's do it. يلا, cosine a cosine b, so 20 over 29 times cosine b 4 over 5 minus sine a sine b, so 21 over 29 sine b 3 over 5, 17 over 145, so k is 17. And this should be the one in the second quadrant. Yep. Second quadrant, what does it mean? Cosine is negative. But when you're finding cosine, you need to use the negative square root. Okay, so let's first find cosine a. It's square root 1 minus cosine square, so is 1 minus sine squared a. Right? Let's do it. Negative root. Why negative root? لأنه إلنا second quadrant. Negative square root 1 minus sine squared a. 1 minus 21 over 29 squared بيطلع لك minus 20 over 29. Okay, و cosine b, لا sine b هلا. Sine b, we don't need to take the negative root because in the second quadrant over here sine is positive, right? Sine b in this case is square root 1 minus cosine squared b. So square root, let's do it on a calculator. 1 minus cosine squared b, so cosine is minus 3 over 5. Let's remove the negative from outside. 4 over 5, right? So sine b is 4 over 5. Here we're using the same rule, huh? Cosine a cosine b plus sine a sine b. Okay, yalla. Cosine a, we found it minus 20 over 29. Cosine b, we found it, it's given minus 3 over 5. Plus sine a, which is 21 over 29. Sine b, which is 4 over 5. K is 144. Thank you so much for watching. Good luck in your exam.